So, yep, everything looks good. I'm just gauging the room. Yeah, so welcome friends. Is it too loud? So, yeah, this is like a very weird, feels a bit weird. Like, yeah, I'm trying to get used to it, but it's fine. So, thanks for coming to this talk among all the awesome, amazing talks. So, welcome. Today we are going to talk about passwordless future. So, let's begin. I'm Deepu Sasidharan. I co-lead the JHipster project. I'm a Java champion. I work as a developer advocate for Okta. I'm a polyglot developer. I built a lot of open source stuff. I like to work with Rust, Java, Go, JavaScript. These are my favorite languages. So let's begin. First things first, right? Like, why do we even have to go passwordless? I mean, we have been using passwords for like, what, 1,000, 2,000 years or whatever. And it's convenient, right? Like we share our Netflix passwords, Prime passwords and stuff. It's quite convenient. So why do we need to go passwordless, right? So I think the most important problem is the password problem. It's the password is a problem, right? So Verizon does this yearly survey. It's called the Data Breach Investigation Report. So according to the 2023 report, credential-related issues, especially phishing and all these things, they account for like 65% of all data breaches. So 65% of all data breaches involve some sort of password-related things, right? So that's a problem, right? And I don't think, as a species, we are that evolved, to use passwords properly, to keep them safe, and stuff like that. I don't think so. And most of the password problem are actually human problem. It's not the technology that's the problem. It's us. We are the weakest link in the entire chain, right? Because passwords rely on us humans to do a bunch of stuff like keep them safe, not to share them, not to write down in a piece of paper and put it somewhere, these kind of stuff, right? And yeah, history has a gazillion times shown us that we are not good at that. We don't do that. We always screw things up. So that's on us. That's not on the technology. So it's technically a human problem, right? So let's see some of the, in more detail. Let's see in detail what other are the issues of passwords, right? So the most important problem with password is it's knowledge-based, right? And being knowledge-based, it means it's a hassle to remember. If they're easy to remember, which means they're also easy to hack in and like easy to guess. And if they're complex, they're hard to remember. So we tend to reuse passwords when it requires to be complex. And like today we use like thousands of services. There are like so many passwords to remember, and who has the brain capacity or the time to remember so many passwords? So a lot of times we end up reusing passwords, and most of us who are at least the tech savvy among us, we end up using a password manager. But if you look at the general population, not so much. Not many people use password managers, right? Tech folks, we end up using password managers. How many of you actually use a password manager? How many of you don't use a password manager? Come on, don't be shy. Okay. I had a joke about that. Never mind. Mean folks. Anyway, and most importantly, passwords being knowledge-based, humans can be easily socially engineered, right? If you look at most of the hacking incidents or most of them are always social engineering. It's not very complicated people sitting in hacking stuff. No, it's just people going to people, social engineer them, say some good things, say some lies, get their stuff done. That's it. Most of the time, it's like 14-year-olds sitting somewhere and doing these things, right? It's not a complicated setup and stuff that ends up doing data breaches and stuff. So next issue is phishing. How many of you have accidentally at least visited a phishing website? Oh, good crowd. Nice. And how many of you have actually entered your details into a phishing website? I know many of you are lying, but still, good. So, I mean, even if you are very tech savvy, there is a chance you might at least consider going to the website sometimes. But yeah, phishing. Phishing is a huge problem, again, with passwords, right? Another issue is remote replay. Since these are like knowledge-based things, if someone gains your password, they can access your stuff remotely unless you have like a MFA setup and all these security. They can access your stuff remotely, and sometimes you might not even know that they have access to your stuff. That's also a problem, right? And the next problem is data breaches. Since passwords needs to be stored somewhere, so the service that you're using, they have to store your passwords. So those services becomes a target for data breaches. So hackers can hack them and get passwords, and that's a problem, right? The next problem is sharing and reusing. How many of you don't reuse your passwords? Okay, more truthful. I have a lot of passwords that are reused. I cannot remember a lot of stuff. So in places where I cannot use my password manager, I tend to reuse at least the complex ones of my passwords. And of course, we end up sharing passwords. How many of you share your Netflix password? At least used to. I did with a bunch of people. So another problem with passwords is password management, right? They're not just a hassle for the end user to remember and all those things, but as a service provider or as a developer, you have to do a lot of stuff when you're doing password-based authentication. You have to implement recovery flows, reset flows, multi-factor authentication. You have to secure your database, like additional protections and stuff to secure the passwords. A lot of stuff. You have to be compliant with a lot of things when you store passwords. It's just a hassle, right? And in some use cases, you need to rotate your passwords, you need to reset them regularly, enterprise use cases, like all those things. So it's just a hassle. Did you know that it costs around like $70 to $100 to reset a password? Apparently so. That's the cost of resetting a password. So yeah, as I mentioned, password managers do help, and everyone should use one. Is it sounding weird? Ah, sorry, I didn't notice that. Sorry about my beard. Where was I? Yes, password managers. Yeah, so we should all use a password manager, but password managers don't solve all of this issue. It might solve the password being hard to remember kind of issues, but it doesn't solve all the other issues. You can still be phished and all those things, right? So before we go further, let's look into what is passwordless. Because of course, if password is a problem, the obvious solution is to go passwordless, right? So if you can verify a user's identity without using a password, that's passwordless. Quite simple, right? Like nothing fancy there. And I think most of us are using this in some form or the other. Our phones, biometrics. We might be using many forms of passwordless already, right? And there are few passwordless methods that other than the phone stuff you might have encountered, like biometrics in your phones and stuff, of course. You have magic links. Some services send you magic links without passwords. You just click on it, but still a hassle. It's not very convenient. SMS OTPs, email OTPs, again, not very convenient. It's like, okay, passwordless, but not very convenient. It's there. Push notification, I think Google and all, sends push notifications mostly as a second factor, but it's still there, but sometimes as a first factor as well. So these are the current passwordless authentication, right? That is where passkeys come into the picture. So passkey is a unique cryptographic key pair with which you can access online services. So that's a passkey, right? It's based on asymmetric public key cryptography, which means it uses a private and public key. We'll go into details of that. So in my opinion, a secure passwordless future is the one offered by passkey. So this should be the passwordless solution. The others are not that convenient and not as safe as passkeys. So how many of you have actually used passkeys already? Awesome. So because Google, GitHub, and like many other services have already started rolling out passkey support, so you can already go into your Google account and set it up if you like. How many of you think passkeys is the same as multi-factor authentication? Nice. It's a very it's a much better crowd. The last time I asked this question, there were a lot of people who thought they were the same thing. I mean, they're very similar, but not the same thing. We'll go into that as well. So let's dive a bit more deeper into passkeys. But first, we need to understand some of the technologies that actually makes passkeys possible. Most of these technologies are around us, has been around. It's not something new. It's just the passkeys. The usage of passkeys is only the new thing. So let's do a refresher on public key cryptography. I'm pretty sure most of you know this, but still, I'd like to go through this. So asymmetric public key cryptography involves a pair of mathematically linked keys, right? So you have a public key which can be shared openly, and you have a private key that needs to be kept secret by the owner of the keys, right? So the key pair can be used for two purposes. First is encryption. So if you encrypt a message with the public key, it can only be decrypted by the private key. So that's one use case. And the second use case is digital signatures. So if you sign a message with a private key, you can verify that signature using the public key. And this is the aspect of public key cryptography that passkeys actually use for its implementation. Next piece of the puzzle is Authenticator. How many of you have an Authenticator device? Actually, all of you have an Authenticator device. Your smartphone is an Authenticator device, right? So Authenticator is a hardware or a software entity that can create asymmetric key pairs, so which can be used for registration, authentication. So there are two types of authenticators. We have platform authenticators, which are built into your devices, like Touch ID, Face ID kind of things from Apple, Windows Hello, the biometric TPM combinations in your phones, your laptops, these things. Then we have roaming authenticators, like YubiKeys, Google Titan, and your smartphone, as I mentioned. Your smartphone can be used as a roaming authenticator, right? So these are the two types of authenticators we have. The next thing to understand, or the standard to understand, is FIDO. So FIDO stands for Fast Identity Online. It's a global group of security experts with the goal of making everything secure using passwordless features, and they aim to solve all the password problems. So the standard is based on public key cryptography. It was developed by the FIDO Alliance. FIDO credentials are the passkeys are also called like FIDO credentials. So FIDO credentials again are cryptographic key pairs that can be used for authentication. So FIDO 2 is the specific standard that makes passkeys possible. FIDO defines certain standards, and out of that, the FIDO 2 is the one that we use for passkeys. Again, FIDO 2 consists of Web Authentication standard and the Client Authenticator protocol, CTAP. So these two together makes the FIDO 2 standard. So let's break them down one by one. So Web Authentication. How many of you are familiar with Web Authentication? Nice. How many of you, if you have implemented it in some way for some purpose? Nice. So Web Authentication is the W3C specification that lets a web page use a set of JavaScript APIs to talk to authenticators, like roaming authenticators or platform, doesn't matter. Talk to authenticators and to do authentication based on these. So WebAuthn uses browsers. The browsers have a credential management API, which is another W3C standard. So the WebAuthn underneath uses the credential management API to do all this, but it's a standard on top of that. The WebAuthn architecture consists of three main entities. So one is the Authenticator. We saw about that. So the Authenticator confirms presence of a user, either by biometrics or by touching one of your keys, some sort of presence detection, right? Confirming your presence. Then we have something called a relaying party. So relaying party is nothing but a server. It can be your own custom web server implementation, or it can be an identity provider like Auth0 or something like that. Regardless, that would be your relaying party. So the relaying party is the server that actually requires the authentication, and it is a server that will issue challenges, it will store your public key, these kind of things. So that's your relaying party. And the third piece of the puzzle is a client. So client is just basically your browser and your browser's user agent, along with the actual user. So that forms your client. So these are the 3 parts of the WebAuthn architecture. Next one is the client to authenticator protocol. So the FIDO client to authenticator protocol is used for communication between the authenticators and WebAuthn. So authenticators can communicate over USB, NFC, Bluetooth. So WebAuthn uses this particular protocol for this communication. So we saw all the underlying technologies. That's out of the way. So let's talk a bit more about how exactly passkeys work. So the term passkey it's just a marketing term, actually. It was popularized by Apple and Google. Originally, it was called FIDO multi-device credential, but that wasn't attractive enough for mass adoption. And who wants to go and say, hey, please use FIDO multi-device credentials, right? No. So fancy terms, passkeys. The definition kept changing a few times. The most recent definition is that any passwordless FIDO credential that are discoverable by browser is a passkey. That's the latest definition of a passkey. It's still evolving. Passkeys are still evolving, so that this might change a little bit here and there. But for now, passkeys is the term used by everyone. It's the term used by FIDO, by all the big companies. So yeah, I think probably it will stick. Passkeys actually have 2 variants. So we have a synced passkey. So synced passkeys actually have a better user experience. So why it is called synced is because in this type of passkey, your private key, when the asymmetric key pair is generated, your private key actually gets synced between your devices by whatever ecosystem you are in. For example, if you are in the Apple ecosystem, Apple syncs your, and let's say you create a passkey in your iPhone, right? So the device creates a public-private key pair. Apple syncs this private key in Apple's, I think the thing is called, what is the iCloud keychain, right? I'm not a Mac guy. Yeah. So iCloud keychain. So it syncs it in iCloud keychain, and it synchronizes this private key across your devices. So next time you go to your Mac laptop, your private key is already synced to the device's authenticators. So you can already use that passkey on that device. Same with your iPad or whatever. So regardless of where you go, based on your user account, Apple syncs this across your devices. So that's why it's synced passkeys. Similarly, Google also does the same with Google's, I think Chrome's password manager. I think it's called Google Password Manager now, I think. Yeah, the Chrome Password Manager, right? It does the same. Similarly, a lot of password managers like Bitwarden, 1Password and all, they also started providing this synchronization service across your devices. And with some of the service, it's ecosystem agnostic, but with something like Apple, it is a bit more closed in its own ecosystem. But because of the synchronization feature, it's much more convenient. And when passkeys become more widespread, this is going to be the variant that is going to be used by most of people other than tech folks. Because the next variant is most probably only going to be used by folks like us in the tech industry, right? Another advantage with synced passkeys, apart from the better usability, is that you only need to do enrollment once in one device, and it gets synced everywhere, so you can just use it everywhere. Can be restored on device loss if you lose the original device where you created the passkey. Doesn't matter. You can get it back in a new device in the same ecosystem. So you get a new iPhone, register it with the same Apple ID, and you'll get it back. So all this happens automatically by from your platform. The only downside with this is it's slightly less secure than the next variant, which is hardware-bound passkeys, because there is this aspect of your private key being synced to the cloud. So, it's not just synced as it is again encrypted before it is synced. So it is way more secure, definitely, but theoretically there is a chance that it can be breached. Let's say Apple iCloud gets breached, that means your private key gets out, and then if someone can get your decryption key, theoretically can be decrypted. So a theoretical possibility. So the next is hardware-bound passkeys, right? So the main difference between these is in a hardware-bound passkey, the private key stays on the device. It doesn't leave. It doesn't go anywhere. It stays on the device. So if you use a YubiKey, so I use a YubiKey because I'm on Linux, and platform authenticator is not a thing in Linux. I mean, I do have a module, but yeah, sorry. Yeah, nobody in Linux cares about that, so apparently. Anyway, yeah, so the private key stays. So if I create a hardware-bound passkey using my YubiKey, the private key is actually stored on the device. When you use a YubiKey as a MFA, that's not the case. I'll come to that later. But for a passkey, it actually stays on the device. And for example, I have a YubiKey with a biometric sensor. It can actually store 25 passkeys. That's it. So that's a small limitation, right? So that's the main difference. And because of that main difference, it may not be as convenient as a sync passkey. So this kind of passkey probably is not going to be widely adopted by general public. Nobody wants to buy YubiKeys other than us. Like, we are the only folks who even know what a YubiKey is. So, and again, you need to enroll on each of your security devices. So if you have like 5 YubiKeys, you have to enroll all of them in order for it to use them. You can't just like sync or stuff. There is some talks of maybe overcoming this, but for now at least, there is no way to get this synced or whatever. And again, there is no recovery or backups when you use a hardware-bound passkey. If you lose your key, it's gone. So a good practice is when you use a hardware-bound passkey, you should register multiple as a backup. So you should have a backup security key. You can also use your phone as a authenticator. So that's also a way. But this is the most secure option. So for people in very high security domains like administrators or whatever, if you want to use passkeys, then this is the best bet. This is most secure because you need to physically have the key. You don't have to worry about it being synced anywhere. And unlike multi-factor authentication, where for YubiKeys you only need to touch the device, for passkeys, if you're using a YubiKey, it always requires some sort of authentication, like a biometric or a PIN or something. So it's like 2 levels there on the device itself, right? So as I mentioned, I use the YubiKey. I don't have any. I do have sync passwords, sync passkeys with my phone, which I can use on Google Chrome with my phones and except my laptop. I can use those. But for everything else on my laptop, I use the YubiKey. I don't find, like, practically I don't see a lot of disadvantages except the fact that I have to enroll multiple of them and I have to carry them around, and I always forget to take my YubiKeys. So I always have to remember to kind of, oh shit, if I'm going somewhere, take my YubiKeys. And I have like 3 or 4 of them. Like, okay, take all of them. Where are they? Like, they are plugged in like all different devices. So go take all of them. So coming here, I was like, okay, where are my? I couldn't find one YubiKey. So searching all over my house. Where is my YubiKey? So that's inconvenience, I would say. But it's still secure. It's still way better than using a password plus MFA combination. It's slightly more convenient than that, I would say. But still, not as convenient as sync passkeys, right? So let's see how the magic actually happens, how the flows actually work. So let's start with the registration flow. So in the registration flow, so let's say user begins registration. So they go to a cool website or whatever, they click on register, and it sends a request to your server to get a challenge. So the server generates a random challenge string. It's just a random string. It generates that, it sends a challenge back, and the device where you are trying to do this, the browser, whatever browser in whatever device, right? It invokes the navigator.create.credentials, navigator.credentials.create method of the WebAuthn API, right? So when this method is triggered, it actually sends a request to your authenticator. So if you have a platform authenticator or hardware-bound roaming authenticator, doesn't matter. It talks to the authenticators, and you have to show your presence by touching the authenticator or by your fingerprint or Face ID or whatever. You provide you authenticate your presence, and the authenticator, either the platform one or the roaming one. So the device is actually responsible for creating the keys. So the YubiKey, in case of hardware authenticator, so when I touch the key, it actually creates a public-private key pair. And this public-private key pair is actually stored on the device. And in case of sync passkey, So the key pair is created, and also the key pair that is being created is tied to the domain of the service that you're using and the user. So it's tied to these two. So it's unique for the domain user combination, this passkey or the asymmetric key pair, right? And in case of a sync passkey, the private key is synced to whatever cloud your platform uses. And next, an attestation object is created. So it's nothing but an object that contains your public key from the key pair. It has the signed challenge, because when the key pair is generated, the authenticator, the implementation, uses the challenge string that you got originally. It signs that challenge using the private key generated. Then it puts that challenge, signed challenge, the public key generated, and all the certificates and stuff required for validation and authentication into an object, and it's called an attestation object, again, and a hashed encrypted kind of object. And this object is sent to your relaying party. So your front-end implementation, or via your backend or whatever, it sends this particular object to the relaying party. So once the relaying party gets all these metadata, the relaying party, which is your implementation, again, this is the part where you can choose to do or not, but a good practice or a common practice is to verify the signature, to double check that everything is right, so that the whatever authentication or the registration that happened is for the challenge that you issued. So the loop completes. So you verify the signed challenge using the public key, and then you store that particular user's public key in your database. So probably you already guessed how this is better than passwords, right? Because you're only storing a public key. We'll come to that later. So this is the entire registration process. Then, of course, it goes into your database, all those stuff, right? So this is the registration flow. Of course, it's not just the public key that the server could store. You could choose to, again, it's up to your implementation. You could choose just to store the public key, but most of the times you would want to store a username to kind of tie it to, and maybe like some sort of credential IDs and these kind of things. So you have more metadata and like what type of authenticator they use, these kind of information. So you store all this information. So let's see how, once you have registered, let's see how you can authenticate. So the login flow is quite similar. There is a minor difference. If you just look at the entire picture, you might think, oh, it's the same thing. There are slight differences. So again, the user begins, the login. You go to the page, you click on login. You issue the website's front-end implementation. It asks for a challenge from the relaying party or your server. You get a string challenge. Again, then you call the WebAuthn API, but this time, instead of calling the create method, you call the get method, which is the authentication API method. So when you call this method, the authenticator retrieves all the private keys stored there and filters it down by your domain that you're trying to authenticate to, and it presents that to you. The browser presents that to you. This is the discoverable part. So browser can discover all the keys for that particular domain, and it gives you like, so if you have like 5 keys for a particular domain, it shows you 5 keys for these usernames. So you can just select which one you want to use. And if you have only registered 1 passkey for a particular domain, it will just show you that, and you just click on that. That's it, right? So again, you are showing your presence here by touching a fingerprint or something. For sync passkeys, so the passkey is retrieved. For sync passkeys, if it's a new device, the private key is synced from the cloud to the new device. If it's not a new device, then that part doesn't happen. That's the only place where things differ between hardware and sync passkeys, this particular step, right? So once this happens, you choose your username for which you want to use the private key. You click on your username, and the authenticator takes that private key, signs the challenge using the private key, creates an assertion object. Earlier, it was an attestation object because you're attesting. You're registering, so you're attesting. So this is you're asserting, so it creates an assertion object which contains the signed challenge and a credential ID for you to identify for which credential this is, right? Again, once that happens, you pass the assertion object back to your server. The server has the public key already, so it takes the public key, verifies that the challenge is indeed for the challenge that you issued. Verifies the signature of the challenge, and that if it matches, which means you possess the right private key, so you can be authenticated, so you are authenticated. So this is the entire authentication flow. So why passkeys, right? Like passkeys are superior to password plus like traditional MFA. When I say traditional MFA, I'm talking about SMS, OTPs, email OTPs, these kind of multi-factor authentication or second factor authentication. It's way superior and convenient and secure than this combination. And it is as secure and slightly more convenient than password plus FIDO MFA. So FIDO MFA is where you use your biometrics, YubiKeys, and these kind of things. It's much more secure than OTPs and stuff. And passkey is as secure as this and slightly more convenient. We'll come to that. And most importantly, you don't have to remember anything unless you're like me and you forget your YubiKeys, you know. So for sync passkeys, you don't have to remember anything. So we saw the problem with passwords, right? So let's see how passkeys can fix each of them. So passwords are knowledge-based, right? But passkeys are just discoverable credentials. You are not remembering anything. Your device does the remembering part for you, right? So browsers can autofill them for a service, making it unnecessary for you to even remember your usernames. So you just need to choose when it shows you something. And most of the times you're not going to have a lot of things, unless you're doing testing and stuff, you're not going to have a lot of credentials for one website. Most probably you might have one or two, or I don't know. If you have a lot of online identities on the same thing, maybe a lot. So again, so it doesn't rely on something you know, instead it relies on something you have, which is way more secure and cannot be socially engineered. You know, when it is, okay, unless you let the person in and like you just hand them over your YubiKeys, even then they still need to get either your biometric or your PIN, but still is hard, still very hard to socially engineer, right? So another problem we saw with password was phishing, right? And passkeys are phishing resistant. They cannot be phished because the keys generated was tied to your domain and user, right? So for phishing, it's not going to be the same domain, right? The domain is different. So if you go to a phishing website and try to enter a passkey, nothing is going to work because first of all, the browser is not going to show you any passkeys because it's a different domain. So, and even if you somehow manage to take the things and put it there, it's not going to work because the keys are not going to match with the domain. So it's not going to work, right? So it is phishing resistant, making it impossible to work on spoofed websites. Next thing was remote replay, right? Passkeys cannot be remotely replayed, right? So it is remote attack resistant because you physically need something. You either need to be physically present to touch the YubiKey or cut your finger and maybe put on your biometric or whatever. So someone has to be physically near you. So someone cannot sit on another continent and breach your accounts. So that's impossible with passkeys, right? So the next problem we had was data breaches because we store passwords, makes it very attractive for hackers to hack into your databases. But now you are not storing passwords, you are storing public keys, which is public. So someone gets access to your public keys, doesn't matter. So they're not going to get anything out of it. So it makes your servers less attractive for hackers. And next thing was sharing and reusing, right? Unlike passwords, passkeys are very hard to share, and I mean you cannot reuse them because they are always going to be unique for the particular service user combination because the device creates them. And most of the time, I mean they're not shareable except for Apple. Apple being Apple decided to make it shareable via AirDrop against the spec. So other than that, you cannot share passkeys. In other platforms, you cannot share passkeys. That's why I have an asterisk there. So next issue we had was maintenance of passwords. Passwords are hard to maintain for developers, for us. Passkeys are easier. In case of sync passkeys, you don't even have to take care of recovery flows and all these things, right? Backups and all these things, because your platform does it for you. So much more convenient. And if you're only supporting sync passkeys for your website, you don't have to implement any of these flows. Recovery, password resets, you don't have to implement any of that. All that is taken care by Apple or Google or whatever the user uses. If you're supporting hardware-bound passkeys, you still do have to provide some sort of recovery flow because the nature of hardware passkeys, if you lose your token, then you lose your passkey. So you have to provide some sort of recovery mechanism, but it's still going to be simpler than the current things that we do for passwords, because you don't have to do multi-factor implementations and all these things. So maintenance is still going to be easier. Another thing that passkeys can do is cross-device authentication. So I spoke about platforms or ecosystems being closed in some cases, right? For example, Apple, right? But passkeys also has a mechanism where, for example, you can use your Android phone as a passkey on your Apple ecosystem. It's called cross-device communication. It works via Bluetooth. So you can use your phone as an authenticator for your Apple ecosystem if you want to. So it's not really closed in that aspect. So there are a lot more flexibility. So when it comes to security and usability of passkeys, right? In my opinion, they are way more usable than most other combinations. And definitely they are like, so hardware-bound passkeys are definitely the most secure option. This is, even if you take password plus hardware token MFA, hardware-bound passkeys are way like secure than that, right? And then sync passkeys are as secure as your password plus FIDO MFA combination. Slightly more convenient. I put them higher in convenience. And then you have all your other stuff like OAuth, social login, all the other kind of things. Of course, the security aspect is factual, but the usability aspect is personal choice, right? So this is my take. I don't know if you would agree, but if you like, you can go to this poll and choose your own. And at the end of the talk, we can see if it matches with my usability assumptions, or if you think differently. So please do this if you like. Yeah. Okay, I'm going to move on. I don't think I have a lot of time left. So let's see passkeys in action. So I'm going to show a small demo. Where am I? Okay, I'm in the right place. Yes. Is it visible, or should I make it slightly bigger? Bigger. Is it enough? Or bigger? Bigger. Yeah? Okay. Oh, it's actually good. I can also see it properly now. Okay, so so let's start with where was I? Yeah, let's start with creating a simple Spring Boot application. I mean, this is almost cheating because I'm going to use Auth0 for the passkeys part. Auth0 does all the heavy lifting. Advertisement, yay! Auth0 does all the heavy lifting, so I'm just going to implement that. So it's basically cheating, but you still get the feel of how it works if you haven't seen this in action already. Most probably you have already seen passkeys in action, but still, let's go with that. So I'm going to create a Spring Boot application using the Spring Boot starter. So if you see, you have there are two dependencies, Web and Okta. So Web brings in all the Spring Web dependencies. Okta brings in the Okta Spring Boot starter, which automatically configures OIDC using Spring security and everything. So it does everything for you. You just need to put in your credentials and it works. Magic, Spring Magic, Okta and Spring Magic. So CD. Okay, so we have a simple application. Yeah, so very simple. I'm not going to go into the application. It's very simple application with a main application class and all the standard Spring stuff. So I'm going to create a controller now because I need a controller. So I'm going to create a controller. I'm going to add some basic code for that. Yeah, very simple. Just get mapping for my root path. That's it. It's going to return your username. Very simple thing, right? So I have my controller now. Okay, now I need to create an Auth0 application. So I have already configured my Auth0 CLI and stuff. So I'm not going to go into all the installation login parts. I'm just going to directly create an Auth0 application. I'm going to create a regular web application on the Auth0 side. This is going to be a OIDC resource server, OIDC server. 10 minutes, awesome. I'll try to finish it in 10 minutes. I'll finish it in 10 minutes. So let's create this application. I'm going to get, oh, the net is slow, damn. Okay, yeah, no, it wasn't slow. It was stuck for some reason. Okay, I got my application. So now let's create application properties file. Let's put some stuff in the application properties file. So I need, what do I need? I need my client ID. And I need a client password. So client secret. You can see my secret. It's okay. It's a throwaway application. You can't hack me with that. You can try. Okay. I think it's in order. Yeah, I already have my issuer because it's the same issuer I use all the time. So I think everything is ready. Now I can start the application and show you the demo. I didn't do any sacrifice for the demo gods today, so whenever I do demos, always ends up having something. Hopefully today is my lucky day. Yeah, seems like. Yeah, so since I didn't do any special things, it directly is going to take me to the authorization page. Accept. Yeah, so wait, it didn't even let me do the passkey thing. Damn it. So I'm going to do in a private window. Yeah, so now I can sign up. I will sign up with yeah, some email, random email, and create a passkey. Ah. See, I told you. Sorry? Yeah, but it's a private window. It shouldn't have a cache. The regular one, I think I was already logged in there, so it kind of... Yeah, I know. I'm gonna clear the... Now, /logout doesn't work if I don't do the security configuration. So I need to add a security configuration for that to work. Okay, this is the last try. Otherwise, I'm going to just ask you to go to the GitHub repo and try it yourself. Ah, damn it. Okay, I'm going to show you another one then. I'm going to show you my next demo. So my next demo was supposed to be, yeah, So I was going to, okay, I'm going to continue and show you another demo. So of course, you don't have to use an IDP for passkeys. You can implement it yourself with WebAuthn for Java. So we have two libraries when it comes to WebAuthn. 5 minutes? 5 minutes, right? 7 minutes, okay, yeah. So we have two libraries when it comes to WebAuthn on the Java side. WebAuthn for J is the more complete one, I would say. It's FIDO2 conformant, supports all attestation formats. It's suitable for laying party server implementation, supports passkeys. It is used by Keycloak and Spring Security, Kotlin friendly, all those stuff. We also have another one called Java WebAuthn Server, which is from Ubico. It's not 100% FIDO2 compliant, but it still supports most attestation formats and stuff. So that is also an option. So I implemented a very small application with Spring Security. So I'm going to show you that demo. I'm not going to like live code or that. But I think the problem is what you mentioned. I think I was already logged in there, so for some reason it's acting weird. Because I think I was trying it yesterday and I probably didn't clear things properly, right? So I have this small demo. Yeah, basically, again, a Spring Boot application using WebAuthn for J as a laying party side implementation. Oops, sorry about that. Okay, let's start this up. This should work because this doesn't use any IDP or cache or cookies and stuff, so this should work. Okay. So I'm going to sign up. Let's say, so it's going to, the browser is going to ask me for a passkey. So as you can see, you can use your phones to create the passkeys, or you can use security key. So I'm going to use my security key. So I touch my security key, yes, allow, and I'm registered, right? So I can now go in and sign in. So when I do sign in, it's going to show me the things that I have. So if I, let's say if I go and register one more, let's say I registered for another username, and I go to sign in, right? I probably have to refresh. It's not my lucky day. It's definitely not my lucky day. Things that normally always works, always, even when I practiced yesterday, everything works perfectly, and when I actually do it, every single time, makes me want to, I don't know, believe in demo gods or something. I have no idea. Honestly, I have no idea. It should list like all these things. Yeah, that's the point, right? It's the same domain. So I created with multiple users, so it should list all those users here because it's for the same domain. So when you go to a same domain and the browser sees, hey, there are like 5 passkeys for this domain, it lists all this. So it should be like one after the other. So then you just select whichever user you want. And then authenticate with that. But anyway, let's go with this. You authenticate. Oh, come on. Yeah, I think. Yeah. Now it works. Now it works. So it lists everything that's stored there, and looks. Damn. Every single time. Yeah, I'll finish in 2 minutes. Okay. Doesn't mean that there are no challenges with passkeys. There are still some challenges. I think the biggest problem with any other W3C stuff is the OS and browser dependencies. And we all know how that works out, right? So browsers are going to implement it slightly differently. You can already see this with Chrome and Firefox. The implementations are slightly different here and there. The user experience is slightly different. So yeah, we are going to continue to having this browser wars, like implementing their own stuff, and operating systems like Apple doing their own stuff. So we are going to have that. I don't think there is any way around these things. And the next problem is cloud vendor reliance. For sync passkeys, we have to rely on Apple, Google, or Microsoft. So again, we are giving more control to these big companies for our authentication stuff. So that is a valid concern. There are enterprise use cases which may not exactly work, especially for sync passkeys. For example, a lot of enterprises might not allow, let's say, Google Cloud or Apple, what is it called? The iCloud? Yeah, iCloud. Yeah. So they may not allow that, right? And in those cases, you may not be able to use sync passkeys with those services. You might be able to use it with the password manager, maybe, if it is allowed. But yeah, you have to work around these things. And in those cases, you can still use hardware-bound passkeys. But yeah, these could be an issue. And reset and recovery for hardware-bound passkey is still not something exactly figured out or specced out. It's not in the specs. There are some talks, and the Ubico is doing some works around this. They are trying to get some sort of spec around this to have recovery, maybe some sort of replication of devices or something, some sort of recovery mechanism, still under the work. But for now, if you want to support hardware-bound passkeys in your application, you have to implement some sort of recovery mechanism in case people lose their keys. Browser compatibility is still catching up. I forgot to put my phone in silent. I'm sorry. So yeah, browser compatibility is still catching up. For platform authenticators, it's okay. You can see Linux, very sad state. I'm really sad about that. I always think about that. Every day I think about that. I wake up and think about this first thing in the morning. So why? Anyway, when it comes to roaming authenticators, it's much better. You can see Linux. Yay! I'm very happy about that. Happy about all the work that Ubico has done to do all this stuff. But yeah, roaming authenticators have much better browser compatibility. And how much? We have time. Okay, done. 10 seconds? 10 seconds. Yes. Yeah. I talked about FIDO was MFA, right? Doesn't actually differ too much because both can be implemented using WebAuthn. So the underlying things are all the same, the flows are all the same, the mechanism is almost the same. The only difference is passkeys are resident keys, which means the stuff is stored. Damn, someone keeps. Let me put it in do not disturb. Yes. Yeah, bad time for people to call me. Anyway. Yeah, so resident keys, which means it stays on your devices, whereas FIDO MFA, actually if you use a YubiKey for FIDO MFA, your private key doesn't stay on the device. It actually does this weird sort of encryption and all these mangling and actually sends your private key also to your server in a very different way. Ubico has a full blog about it. It's very interesting. If you're interested, check it out. It's extremely interesting how they do it actually in order to increase the capacity because it can only store a limited number. So they make it unlimited by using this method. Yeah, it's very interesting. If you're interested in cryptography and stuff, check it out. Extremely interesting stuff. Yeah, that's the main difference. Other than that, they're almost the same, and the usability is slightly different. Synced option. MFA doesn't have a synced option. MFA can only be second factor. You cannot use it as first factor, unless you specifically implement it that way somehow. Passkeys are first factor. So that's the main difference. Other than that, underlying technology, everything is almost the same. Some resources if you want to learn more about these. And we have a passkeys login challenge at our booth. If you want, come check it out. We have some gifts. And yay, Auth0, use Auth0. You won't have the problem that I had today. That's my bad. And thank you everyone. Thanks for coming, thanks for your time.